So as I mentioned, here are the hardware implications for the clusters. You have to remember that high-scale, large applications are quite I/O hungry. So especially with the high number of read-writes on the database, so they may require local SSD storage instead of the cloud storage offered by Azure or AWS. As I said, Azure disks, some of them have a limit of IOPS. So for standard disks, I believe it's 500 IOPS. And this requires you to have a RAID setup, RAID 0 or RAID 10, to have a greater number of IOPS for your instance. But this, of course, leads to higher costs and greater management overhead. So the local SSD storage, it's not just the disk, it's also the hardware RAID that we use. It has a better backup unit, and it plays quite a big role in performance. So it's not just the disks, it's also the hardware RAID. So in software RAID, it may not perform as well as with the hardware RAID. Secondly, the nodes can easily be virtualized with any virtualization technology like VMware, Xen, or OpenVZ. And you can launch several instances of MariaDB on a single dedicated server. This will allow you this will allow MariaDB to book CPU in parallel, and because it doesn't always need to use the CPU, other instances can take over and use the CPU when it's idle. So it's a good method to virtualize your dedicated server either on premises or at your provider, and create a cluster out of virtualized nodes, because then you can easily move the virtualized nodes to any other server if you need to scale in the future. And if you have a private network between the dedicated servers, you can easily move the virtual machines across your whole network. And that's what we do actually. We virtualize the nodes, then we place each virtual machine on a separate dedicated server connected to each other via private network. And this allows us to scale because we can grow the cluster at any time. We can take images of the machines and we can store them and do whatever we need. Also, in terms of clouds like Azure and AWS, the good thing about HAProxy and MaxScale is that they know the status of your MariaDB cluster. So the way ClusterControl installs HAProxy is that it includes checks on the database to make sure that your database is available before sending requests to this particular node. And this is an important thing because, for example, Microsoft Azure load balancer wouldn't be sufficient for you to have a load balancing across your database nodes, because it simply does not know the status of the underlying database, whether it's in synced status, whether it's in desynced, or as a donor. So the load balancer actually needs to be MySQL aware, state aware. And in some cases, you may need to install to activate the Microsoft Azure load balancer in front of your HAProxy if there is no support for the VRPP keep alive that Art has mentioned. So if you cannot make the HAProxy instance highly available with the VRPP, you would have to have one more load balancer in front of your HAProxy or MaxScale load balancer. This makes it a bit more complicated, but that's what you can do on your AWS or Azure clouds. And of course, what I wanted to mention to you is that you always have to plan your data structure ahead. because for us, we had to distribute data across different storage types, NoSQL and MySQL, and Galera cluster is actually the perfect solution for failover. But if one node in Galera cluster goes down, it will require a state transfer, a full state transfer SST after downtime. So for example, if you have a large database of 100, 150 gigabytes, then it would have to rebuild the database from scratch, and it will take several hours for you to prepare the node back. So and if you think about it, if you have like a larger database, 200, 300 gigabytes, then it will be a nightmare, and it will take a day or two to copy the data back to the node. So we believe that Galera is perfect for customer-specific data like accounts, billing, user details, and some other customer-specific data. But the rest of the data we're storing in a NoSQL cluster, just because it does not, just because we're capable of managing the number of replicas that the database has. And MySQL sharding, as we mentioned, can be used to scale MySQL with large data sets where you distribute the data across several nodes. But it may be actually difficult to manage and maintain, as there won't be any graphic interface like ClusterControl, and it may require your application to know which database server to pick when querying the data. So it will need to know to which database to go to get the right data. Master-slave replication is also quite common in most organizations, but it may not help you to scale the writes. If you have a lot of write requests to your database, they will still need to go to the master node, and you won't really be able to scale the writes, although it's quite capable of scaling the reads, I would say. And NoSQL cluster, the MongoDB as we chose, is quite suitable for storing large amounts of data nearly out of the box with little management overhead. And the best thing is that it can be added to ClusterControl management panel. So these are the implications and our thoughts on database management as we encountered on CloudStats. If you have any questions, you can always contact us at WooServers or at CloudStats, and we are happy to answer any questions. I think Jean-Jérôme wants to run one more poll right now.
Yeah, thanks very much. Thanks very much, Andrei. And we have a lot of questions from the audience, which we will we'll try to answer as many as possible, of course, before we come to the hour. But I wanted to ask every one of you now in the audience one last question yourselves. And this is just for us, I suppose, to know how we can maybe help you or talk to you in the future, is to see whether you're looking for solutions right now to help you scale your databases and achieve high availability. So maybe you're looking at rethinking a database infrastructure, and you might have some questions there, or maybe you're looking at migrating to a different data store, which also can be quite complex to do, and you might have some questions for that. Or maybe you're just looking for additional information and nothing too concrete at the moment. But it'd be great to get your feedback here. And then we'll look at the questions in the audience as well. So thanks very much for your participation. I'll just give it a few more secs. Great, thank you. I'm just going to close this now, and then we can look at the questions that have come from from some of you today, and there's a good few. So hopefully we can get through some of them now before the hour. And those questions we can't answer right now, we'll just contact you directly after the webinar to go through them.